Hi, today we're going to talk about parallel and perpendicular lines. Notice that parallel lines have the exact same slope. It causes the lines to go in the same direction, such as these two lines. Also, we have the form y equals mx plus b, that's slope-intercept form. So your m value represents the slope of your line. So let's say, for example, we have the equation y equals 2x plus 3. Notice that our slope here is 2. That's our m value. So if I say, I want you to write the equation of a line that's parallel to y equals 2x plus 3, that would be easy. Our parallel slope, remember the two lines, that's the symbol for parallel. Parallel slope would also be 2. So we could write the equation y equals 2 times x, and then you could put any number that you want to afterwards. Let's say minus 5. So y equals 2x plus 3 and y equals 2x minus 5 are parallel lines. Okay, now let's talk about perpendicular lines. Perpendicular lines form right angles. And you'll notice this in the equations because they have opposite reciprocal slopes. So for example, if you have a slope of 3, the perpendicular slope, remember that's the symbol for perpendicular, you're going to make this look like a fraction. You're going to flip it and turn it upside down. So remember 3 is also 3 over 1. So if you flip it, change the sign, the perpendicular slope would be negative 1/3. Okay, if we have a slope of negative 5/4, again, you're going to flip the fraction and change the sign so it becomes a positive 4/5. Now, 0.1, that can be thought of as 1/10, which is a fraction. So if we flip it and change the sign, we get negative 10 over 1, which we could just write as negative 10. Now, the only exception to this rule about opposite reciprocal slopes is when you have vertical and horizontal lines. They're always going to be perpendicular to each other. So remember, a vertical line has an undefined slope. It looks like this. And a horizontal line has a 0 slope. And it's just straight across like that. Notice again, they do form a right angle. So vertical and horizontal lines are always perpendicular to each other. So if you have one slope, let's say that's 0, if you want a perpendicular slope to that, it would have to be undefined and vice versa. So if I have that equation, y equals 2x plus 3 again, and I said, I want you to just make up a line that's perpendicular to this one. All I really need to know is that my perpendicular slope of 2, perpendicular slope of 2 would be a negative 1 over 2. So I could just say y equals negative 1 over 2 or negative 1/2 x. And then you could put any number after that that you wanted to. Okay, let's say we put plus 4. All right, so these two lines are going to be perpendicular. Now, let's talk about what they look like when you graph them. Let's get our calculator, and I'm going to get my calculator out and show you. All right, so let's go to y equals, and let's type in that original line, y equals 2x plus 3. And then we'll do the one that's parallel to that we wrote down was y equals 2x minus 5. And we'll look at those, and they should be parallel to each other. And there you see them. They are parallel to each other. Okay, now let's go back. We're going to keep the y equals 2x plus 3, but remember we said the perpendicular line was y equals negative 1/2 x plus 4. So let's type that into the second equation, negative 1/2 x plus 4. And we're going to graph it. Now, when we look at this graph, it really doesn't look like they're crossing at a right angle. And the reason is because we're in the standard window. Notice your x's go from negative 10 on the left to positive 10 on the right. The y values also go from negative 10 at the bottom to positive 10 at the top. But do you see the spaces between the x values and the spaces between the y values? They're not the same. It's not square. It's not going to look like it would on your graph paper. So in order to fix this, we're going to go to Zoom on your calculator. It's at the top in the middle, Zoom. And we're going to press number 5 for square. Okay, now we're going to press enter and look at our graph. Notice now that these two lines do form right angles. Now the picture that you have on your screen here, this little graph that I have at the bottom of those the third screen there, notice that was the original one. It definitely did not look like right angles. But now look at the new graph and you see that these two lines do cross at right angles. All right, so now let's go back and let's do a couple more examples. All right, let's find a line in slope-intercept form that passes through the point 1, 4, and it's parallel to the line 2x minus 3y equals 5. Now, this is my given line. First thing I need to know about this line is what is its slope. So let's take this 2x minus 3y equals 5. And we're going to solve it for y so that we can see what the slope is. So we're going to subtract 2x from both sides. So we have negative 3y equals negative 2x plus 5. And then we're going to divide everything by negative 3. So we get y equals, this would become positive 2/3 x. 5 divided by negative 3 would be a negative 5/3. So this is the equation of a line in slope-intercept form of my given line. Notice the slope is right there. So my slope is 2/3. So if I want to create a line that's parallel to this line, my parallel slope is also going to be 2/3. So to find my line, I'm going to use a slope that's 2/3. So my parallel slope is 2/3. And I want it to go through the point 1, 4. Now, anytime that you know a point and a slope of a line, you're going to use point slope form. Remember, that's y minus y sub 1 equals m times x minus x sub 1. And we're going to put in values for y sub 1, for m, and for x sub 1. So we have y minus, our y value in this point is 4, equals our slope, we said we're going to use is 2/3, times x minus our x value, point, is a 1. And then we're going to simplify that. We're going to distribute the 2/3. So y minus 4 equals 2/3 x minus 2/3. And then we're going to add 4 to both sides. So y equals 2/3 x. Now, when you add 4, if you think about it having a denominator of 3, this is the same thing as 12/3. So if we're taking negative 2/3 and adding a positive 12/3, that's going to leave us with a positive 10/3. Or you can put it in your calculator if you're not sure. Okay, so this is a line that is parallel to the given line, and it also goes through the point 1, 4. Right, now let's take that same problem, but this time we're going to find a line that's perpendicular to that given line and still goes through the point 1, 4. All right, so we took that 2x minus 3y equals 5, and we already found that the slope of that is 2/3. Okay, so a perpendicular slope, we're going to flip the fraction and change the sign, so negative 3/2. So we're going to have a perpendicular slope of negative 3/2, and we're going to use still the point 1, 4. All right, so here we go. Y minus y sub 1 equals m times x minus x sub 1. Again, we're going to put in values for our y sub 1 and our x sub 1 and our slope. So it's going to look pretty much like the problem above, except for the slope part. So y minus 4, because that's our y, equals negative 3/2 times x minus 1. Again, we're going to distribute the negative 3/2 this time. Y minus 4 equals negative 3/2 x plus 3/2. And lastly, we're going to add 4. Now, if you think about 4 having a denominator 2, 4 is the same thing as 8 over 2. So if we're taking 8 over 2 and adding 3 over 2, that's 11 over 2. So y equals negative 3/2 x plus 11/2. So this is a line that is perpendicular to the given line, and it also goes through the point 1, 4. All right, that was it. Good job.